I'm Professor Jana Levin, and I am in the Department of Physics and Astronomy. I tend to teach mostly physics. Occasionally, I'll teach astronomy. Within physics, I've been teaching electricity and magnetism a lot these days. And one of the reasons why I love that class is because it's a real shift in abstraction for a lot of the students. They've never seen the math at that level, and they've never really had to deal with invisible forces like electric forces and magnetic forces, and it's not as intuitive as maybe some of the science that they've studied. And it's actually really exciting to kind of see their faces light up when they begin to understand a kind of unseen world. I just recently published my 4th book. It's called Black Hole Survival Guide. It's a beautiful little object. An artist friend of mine painted more than 20 original artworks for it that illustrate in this kind of visceral way an astronaut exploring black holes, and kind of the subtle premise is that I'm the astronaut writing the field guide, and she's depicting this kind of exploration in these artworks. It's very short, it's very sweet. I love to dispel some of the notions people have about black holes. One of them is that black holes will catastrophically destroy anything in the universe, when in fact we are in orbit around a black hole. Our entire solar system together is orbiting a supermassive black hole 4 million times the mass of the sun. It's 26,000 light years away in the center of our galaxy, but nonetheless, it anchors the galaxy, and we are, along with the rest of the galaxy, slowly rotating around this black hole, and it is not tearing us apart, nor will it for a very, very long time. I like to say the future is much longer than the past. And if everything proceeds in an unspectacular way, we will eventually fall into that black hole. That is our fate, but it is far, far, far away. One of the other things I like to dispel is people think of black holes as these monsters. Really, the whole point of the black hole is that they're tiny for their heft. So this supermassive black hole, which we fondly call Sagittarius A star because it's in the direction of the constellation Sagittarius, being 4 million times the mass of the sun, is only around 17 or 18 times the width of the sun. So think about how tiny that is. Taking the sun on the sky, imagining it 18 times across, putting 4 million times the mass in that small space, and then pushing it 26,000 light years away. So that black hole for us is about the size of a piece of fruit on the moon. So they're heavy, but they're tiny.